Good day, grade 12 learners. Welcome to today's Technical Mathematics Paper 2 lesson. My name is Moses Maudu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So today we're going to look at Paper 2. The first thing that I'm going to talk to is the mind map of Paper 2. So if you look at Paper 2, the analytical geometry, the marks allocated for analytical geometry is 25. The marks allocated for trigonometry is plus minus 50. The marks allocated for Euclidean geometry is 40. And the mark allocated for measurement, circles, angles, and angular movement, it's 35. So we're going to look at all these topics. We're going to look at what are the skills that we need to have in order for us to be able to get marks in the paper that is going to be written on the 6th on Monday. Right. So now the first thing that I'm going to look at now is the information sheet. Remember, at the end of your question paper there is an information sheet. In the information sheet, that's where you get all your formulae. So I've just cut out some of the formula that we're going to use in analytical geometry. Remember, you need to read the question before you can choose the correct formula. So I've got the formula for the midpoint, for the distance. I've got formula for the midpoint. I've got a formula for the gradient, and there's a formula for the inclination, which is the angle, and the formula for the ellipse. So those are the formula that we use mostly in analytical geometry. Right, the first activity that we're going to look at here. First of all, you must read the given information. That's very, very important. So in this given information here, it says in the given diagram, you're given the coordinates of A. Please check on the sketch if what is given on the information it's there on the sketch. So we have A is given as 3 and 7, and check if the values are correct there. B, it's minus 1 and 6, 1 and minus 6. C, it's negative 3 and 4. And they say they are both the vertices of a triangle. In other words, you are having a triangle given there. The D is the x-intercept of the graph, so meaning that we have that point D there. It says on the straight line AD, so AD is a straight line. K is the point E and F in the first quadrant. E is greater than 0 and F is greater than 0, meaning that the two values, the E value and the F value, can never be negative. So even if you're working them out, the E value and the F value must always be positive. You're given the inclinations alpha and theta are angles of inclination. Remember, inclination is the angle between the x-axis and the straight line from there. Right, so, and we are given angle DCB, which is a beta there. So the first question says determine the coordinates of the midpoint of BC. So what do? I go to BC. Here's my line BC. I need to find the midpoint. Midpoint will be somewhere there. So I need to find the midpoint. So I'm using the point B and point C. So if I use point B and point C, remember the midpoint, the formula, it's m into, it's x1 plus x2 divided by 2. So you go to your formula sheet, you check the formula. So it will be x1 plus x2 divided by 2. And the y value will be y1 plus y2 divided by 2. Okay. So now my gradient, my points of the midpoint there will be, if I check x1, x at C, it's minus 3 plus 1, which will give you minus 2 over 2. And the other one will be 4 plus minus 6, which is going to give us negative 2 over 2. So my midpoint will be a negative 1 and a negative 1. Okay, so these are basic questions. First question, really, this is from the question paper. First question there, you can see it's a basic question. Go to the formula sheet, substitute correctly, and get the answers. Right, please write down the correct formula. Okay, the next question there, it says determine the gradient of AD. So what do I do again? I go to AD. Here's my line AD. I need the gradient. So remember, then I go to my formula sheet. I say, which formula represents the gradient? So I'll realize that the gradient formula is the small letter m, which is y2 minus y1 divided by x2 minus x1. So I look at the line AD and I must locate two given points. Remember, D is not given. So I locate two given points. So if I locate two given points, I've got a C and an A. So I'm going to substitute there. So my gradient is going to be, if I start with a 7, I'll say 7 minus 4. Then if I start with a 3, so it will be 3 minus 3. So it's 3 negative into negative 3, which gives me 3 over a 6. So 3 over 6 means that the gradient there will be 1 over 2. So I've got a gradient of 1 over 2. So you see, these are basic questions, and they're easy, straightforward questions that you need to work on and then get marks. You know, they give you confidence in getting to the next type of questions. Determine the equation. You see, those are questions that are quite straightforward. Now the equation of AD, already, what do I need if I need the equation of AD? I need the gradient. So the gradient is already there. I have the gradient. The gradient of AD is there. I have it. I already got it. And I also need a point. So I can either use this point here or that point there. So I prefer using the positive values there rather than negatives. So then I can choose a point here, which is 3 and 7. So I'll have y equals to mx plus c. Remember, this is the equation of the straight line. So I can substitute. My y value is 7. My gradient is a half. My x is a 3. And I need c. So c, if I transpose all those things there, I'll get c to be 11 over 2. So I'll write down the equation. Don't forget to write down the equation. It's very important. So I'll have half of x, then plus 11 over 2. And that is the equation of that line AD. How do I know I'm correct? The gradient is a positive gradient. I know that I'm correct. 11 over 2 might be somewhere there, so it will be somewhere there. So it's a positive value, so it can also be there. So you can check your answers immediately by looking at the sketch that has been given. The other way of doing that can be you go and use the y minus y1 equals to m into x minus x1. So you can substitute directly, and then you get the equation. So you have y minus a 7, gradient is a half, then you have your x value, it's going to be x minus a 3, and then your y value will be half of x plus 11 over 2 if I multiply out correctly. Okay. Alright, so you can use any of those two. I like this one because it gets you straight to the question, to the answer. Okay. Right, 1.4.1, now you are given that the gradient of the line BC is negative. So you don't need to work it out. You are already given. They say show that the alpha, the angle that is formed there, will be 111.80. Now what do we do here? The gradient is given, so I'm going to go to tangent because I know that the angle that I'm looking for here will be represented by the tangent of that angle. So, and it will be also represented by the gradient. So the gradient is already given, it's minus 5 over 2. I don't need to work it out, it's given. So now the angle that I'm going to get there, I'm not going to get, remember I'm not going to get an alpha there. I first need to get the reference angle. So my reference angle, I use a calculator. Say shift tan 5 over 2. So you don't say shift tan negative 5 over 2. You say shift tan 5 over 2. Then the angle that we're going to get there is 68.20 degrees. Now that's my reference angle. Then the angle that I'm looking for here, remember this angle here is an obtuse angle. So it must be 180 minus. So I'm going to say 180 degrees, subtract the reference angle. Then if I use my calculator correctly there, my answer there will be 111.80 degrees. Okay, and that is what I'm looking for. Remember this, you'll not have a mark for that because it's already given to you. Okay, that's the nice thing about this. Now determine the value of beta. So here I know this angle here is 111.80. Right? So for me to get to this angle here, that angle there, I need to first get to this angle here. Right? So already I know the gradient of that line, so I can get the angle here. So if I get that angle here, I'll be able to get that. I can see that that is a triangle and this is an exterior angle. So this angle outside will be the same as these two. So if I know this one, I'll know this one. Okay, that's a tricky question. So now, first of all, what should I get? I must get the tangent of theta equals to the gradient. The gradient is already, I know, is half. So my angle that I'm going to get there is 26.57. Okay, so for me to get my beta now, it's going to be my 111.80 subtract 26.57, or I can say 180 degrees minus that angle minus that other angle. So but now the easy way will be 111.80 subtract 26.57 degrees, then angle beta there. That's a bit tricky question there. It will be 85.23 degrees. Right. So I know that if this one is 85.23, that one is 26.57. If I add these two angles and add that one, the value of that angle will be 180 degrees. So those two angles here will give you 111.80 degrees. Okay. Right. Another tricky question here. But if you then focus and read the question, you will be able to understand. First, read the question and understand what they want. Here they want the possible values of f. So you are given the e and the f. But it is given that if f is 2e minus 2e plus 1. So what should I do? I need to then come here and then change the f to be 2e plus 1. So in other words, my coordinates are e and 2e plus 1. Okay. The distance for KC, which is from K to C, it's square root of 17. So with the square root of 17, so I know now, if I'm given the distance and we need to find the value of e there, I can be able to get it. So now let's see. I'm going to then start by saying kc squared, it's equals to x2 minus x1 squared plus y2 minus y1 squared. Already I know what is my kc. So kc is square root of 17. So meaning that kc squared will be equals to 17. Alright? Because the square root of 17, if I square this, square that one cancels out, and then we have 17 there. So now, what is x2? So I'm using c and k. So what is my x2 there? So I'm going to start by saying this should be negative 3. If I start with negative 3, what am I subtracting? E squared, right? Plus y2. I've started with a minus 3, so I must start with a 4. So it will be 4 minus, remember it will be 4 minus into 2e plus 1. So I can rather write it as 2e minus 1. So this is squared. So I can see here, I can see in the second bracket here, I can work out the first bracket. The first bracket there will be, I'll get a 9 plus 6e plus e squared. But this, I know I can write this one as, that one, I can write this 3 minus 2e. Right? So because the 4 minus 1 is 3, and then I've got minus 2e there. So then I can just square that one. So I'll get a 9 minus 12e, and then I'll have it as plus 4e squared. So I can rearrange everything here. Then if I rearrange everything there, adding like terms and transposing, I'll end up with 5e squared minus 6e plus 1 is equals to 0. Because the 4e here and that one will give me 5e squared, and then 6e minus 12e will give me minus 6e, and then 9 plus 9 is 18, and then I'll bring over the 17, there's 18 minus 17 is 1. From here I can factorize this. If you don't know how to factorize this quadratic formula, you already know that. So it's 5e and e, and then I'm going to get 1 and 1, and my signs will be negative and negative, because 5e times 1 will be times negative 1 is negative 5e, and minus 1e is minus 6e. So my e will be equals to 1 over 5, or my e will be equals to 1. But the question wants us to get the value of f. So which means I already know that f is 2e plus 1, but I know what e is. So I'm going to say f is equals to 2 times 1 over 5 plus 1, which will give me 7 over 5. Or f will be equals to 2 times 1 plus 1, and that answer will give me a 3. So can you see the two values of f are positive? So remember in the question it was said the E and the F are positive. So if I look at the F here, it's positive, F it's positive. So I take both of them will be correct for that value of F. Even the E values are also positive, so I'll have E positive, F positive, and that is what was asked in the question. So this question is a bit of a challenge. Please make sure that you first understand how to do it, and then you do it. Okay, so the analytical geometry, remember the other questions in analytical geometry will include what we have done last week, which was the circle, x squared plus y squared equals to r squared. The other question will be the ellipse, which comes every year. Please make sure that you understand those two questions again. Right. Now, the next part of the work will be the trigonometry. Remember, trigonometry is plus minus 50 marks, which is a lot of marks. So 50 marks. So which means we need to really work very hard to get to 50 marks. Now, what I'm going to do, the trigonometry that I'm going to do, they can give you up to plus minus 25 marks minimum. So let's check that out. There will be rules that are given in trigonometry, and we have the identities, which are very easy. And I want you to, when you go into the exam, please add this one, the tangent of theta, it's sine theta over cos theta. Please add this one immediately before you start with anything. Add that one because we use it more often also. So before you forget it, right? In trigonometry, remember we work with right angle triangles, the definitions, and also we work with non-right angle triangles where we use the area rule, sine rule, and the cosine rule. First, I'm going to look at the right angle triangles, the definitions. Remember, those definitions are very important. These definitions, they work when we have a Cartesian plane with a circle around. So remember, this R here represents the radius, and this is the x value, and that is the y value. I'm sorry, the x value there, and that's the y value. So now the ratios are defined in that order. Remember, these are the core functions. So these are core functions. So they're just the opposite of the sine, cos, and tangent. Okay, so know which one changes to what. Okay, that's important. Right. The reduction formula, remember the 180 degrees plus here, the 180 degrees minus. We have 360 degrees minus and 360 degrees plus. Right. So they are written in there. So please make sure that you understand that. Pi, it's 180 degrees. 2 pi will be 360 degrees. So we have all the ratios. The sine is positive here. Tangent positive there. Fourth quadrant, first quadrant, second and third. So we must know all those things. Right. Now, the first question that I'm going to look at here is the Pythagoras type question. 3 tan square root of 3 tan theta equals to -1. So which means, what should I do here? I must first draw a sketch. So now I must check. If I take this one and I divide it this side, so I'll have this. So in other words, I'm going to have the tangent of theta, it's -1 over √3. Okay, so where am I going to draw my diagram? So my diagram will be, remember cos is positive here, tangent, and we're starting at 90. So from 90 to 270, where is the tan negative? So tan is positive here, so it will be negative in this quadrant, and that's where I draw my sketch, right? So in my sketch there, I know that this is y, so my y will be negative, my y will be 1. My x is going to be negative square root of 3. So remember, it's y over x. So I'm going to have that. So my angle is that. So what is the next thing that I need to get? I must get the radius, the r, or the hypotenuse. So to get the hypotenuse, I use the theorem of Pythagoras, which is r squared equals to x squared plus y squared. So my x squared here, my x squared is going to be negative root 3 squared. My y is going to be 1 squared. So now I'm going to have a 3 plus 1, which is 4. So my radius there will be 2. So that value there will be 2. So now if I've got a radius, I can get all those ones. So the first one they're asking me is the sine of theta. So if I go to the diagram, my sine of theta here, it's going to be y value over the radius. So my sine theta will be 1 over 2. So I just write 1 over 2. I'm done. Now the cos squared of theta, I'll do the same. I'll go to my sketch. This cos is negative root 3 over 2. So this is squared. So if I square this, I get 3 over 4. And that's all that I need to do. The theta, the easy one for me to write will be to use that sine of theta. So I can then say theta will be sine, and then I put a half. In other words, it will be, because I already have it in A there, so I can say the arcsine of theta, the arcsine of a half will be equals to, so I can use that, it will be 30 degrees. But now remember, this 30 degrees will be a reference angle. There's the trick now. Because the 30 degrees will be somewhere there in the first quadrant, but the sketch is on the second quadrant, which means I must use the reduction formula. So therefore, my theta will be 180 degrees minus 30 degrees, which is going to be 150 degrees. Okay, that one was also very tricky. So, right. Now, the reduction formula, this question every learner must get. Everyone. You need to get that question. Everyone. So let's see what we're supposed to do in the reduction formula and the identities. So remember, 180 degrees is in this quadrant. So, and in this quadrant, the sign is positive. So which means that my first one there will be sine of x without the 180, please. Don't use a calculator. It's without using a calculator. And we are showing, so which means the left-hand side will be equals to. I must make sure that the answer will be equals to 1. 360 degrees is in which quadrant? In this quadrant, and in this quadrant the cos is positive. Am I having a cos? Yes, so I'm going to write cos of x. Put this in bracket. The tangent of x, I can change it. So remember, I said you must then write this one down. Okay? I've got a 1 here. Cos x, there's nothing I can do to it. But I've got cos 180 degrees minus. Cos 180 degrees minus, we have a sign which is positive there, meaning that the cos will be negative. So I'm going to write this one as negative cos x. Okay. Obviously, this cos and that cos will cancel out. I'm left with sine x times sine x, which gives me sine squared of x. This cos x times negative cos x will give me a negative cos squared x. But according to my identities, sine squared of x plus cos squared of x gives me 1. So which means I can then say 1 minus cos squared of x will give me sine squared of x. So the sine squared of x on top there, I can change 1 minus cos squared x to be sine squared of x. Then that will be cancel out. The answer is 1 and is the same as the right hand side. Okay, and that's what we're looking for. So this is identities done in conjunction with the reduction formula. So some of the question you'll find that it makes the reduction formula and then they want you to prove the identities also. Ne? So please make sure that you understand that it's a very, very straightforward question. Each and every learner need to get this. And when we mark this, you get a mark for that, mark for that, mark for that, and a mark for that. So already in this step, you have 4 marks. Then from there, you've got a mark for changing this. Okay, so that will be your 5 marks for this question. Okay. The next question is a trig equation. So I'm just doing questions that you need to really start with in the exam and work them out. Then from there you can come up to those challenging ones. But these ones are quite straightforward and easy. Now let's see. Cos is just a trig there and there. So let's look at it. We are solving for x in between this 0 and 360. So first of all, I must make sure that I have cos 2x on the one side. I've got square root of that, 3/2. So I need a reference angle. So first of all, I need a reference angle. My reference angle will be equal to, remember, I'm still working on the cos of 2x here. So I'm going to get my reference angle to be 30 degrees. Okay. So my 2x will be 30 degrees, but that whole thing there will be talking to the reference angle. All this will be talking to my reference angle. So I need to find the values. Remember, this cos is positive. And I know cos is positive in the first quadrant. Remember? In the first quadrant and in the fourth. In the fourth, I use 360 degrees minus. So I'm going to draw my table here. And I say in the first quadrant, I'll use this one as it is. Okay, so my x value will be 15. Can you see I'm not doing it here? Because sometimes you find it is negative. And if you're used to doing it there, you're going to get wrong answers. In the fourth quadrant, I use 360 degrees. So I'm going to say 2x equals to 360 minus the reference angle. So my 2x will be equals to 330. Of which my x will be 165 degrees. Okay, and that question. These questions we must get. We must get them right. Okay, right. So just understand that you need to first do your table there, and you are using your casts. So you're checking where the cos is positive. And what is the interval that is being given to you, because sometimes the interval might differ. Okay, right, from here we're going to take a 1-minute break and we'll come back after a minute. Okay, welcome back. The next question that we look at is the trig graph. These are free marks. These are free marks. Right? Just call them free marks because you have a calculator with you. You just punch this on your calculator and then you get to your answers. Now you can draw your graph. Now the graph that has been given there is f of x equals to tan x. The first thing that you do, if it's a tan x, you go to your asymptote at 90, but please check if it is 90 degrees and draw a dotted line. You can use a red ink also. Then you go to 270, then you also draw a dotted line. Okay, now if I start using my calculator and punch in the values there, so I can see there's 45. So with tan I know 45, we need 45 because it helps us to get 1. So the tan of 0 will be 0. The tan of 45 is 1. The tan of maybe 89, so you can just try 89 because that will be, so I can then just draw my graph that goes like this and put an arrow there. I can start from 91, tan of 91, so I'm going to get it somewhere there. And tan of 135, it will be -1 there. And tan of 180 is 0, you know, tan of 225 will be 1. Then you can see tan of 269 will be somewhere there. So my graph will go like this, and then from there it goes like this with the arrows. This one has got arrows. I'm done. So the graph of tan has been done like that. Okay. So I go to the sine graph. Then I say the sine of 0. I get the answer. I say -45. -2. So my answer there, I think it will be at -2. Maybe we must just, that was supposed to be -2 there. Let's compromise this one and make it -2. So my graph will be at -2, and then from there at 90 it is going to be somewhere there at -1, and then from there at 135 it will be at 180, sorry, it will be at -2 somewhere there, and then from there my graph is going to stop there at -1. So if that is -1 and that is negative, so this is 1, then I'll have this graph like this. So my graph, obviously my tan graph, remember that is not going to be 1, so we're going to have it at 1 there. So my tan graph will be like this, going with the arrows, and then my tan graph in the second quadrant, but that graph here goes like that and goes like that. It's a sine graph that has moved 2 units down. Can you see the -2 means it has moved 2 units down. From the 0 it moved 2 units. From the 90, remember at 90 it's 1, so it moved 1, 2, the original one. So it has moved 2 units down. So then I don't put an arrow there. I don't put an arrow there, please. Then I name my graphs. This is the G graph. There's the F graph. I'm done. If it's 7 marks, that's your full 7 marks. You've used the calculator. The calculator is giving you the correct graph. I think this is super. This is an easy graph to draw. So this question, every child, you must get this question, everyone. So it's an easy graph to draw. Let's make sure that we know how to draw it and practice these graphs. Use a calculator. Make sure that your calculator is in the correct mode for you to can use it. Okay. Now let's look at the Euclidean geometry. So those questions in trigonometry can give you minimum 25 marks. So you can be able to then move to 30 marks doing the 3D that we have done last week also. So you'll be able to do that. Now in Euclidean geometry, first you read the information, then you make sure that the information is represented on the sketch, and you do that. What I'm going to teach you the skill on how we're going to do this graph, this Euclidean geometry. The skill here is not to look at the questions. So first of all, I'm not going to look at the question. I'm just going to work on the sketch and write down on the side what is it that I can see from the sketch. First of all, I see I have a tangent. First thing, I'm having a tangent. Here's my tangent. I know that there's an angle between the tangent and the chord. See, so that angle between the tangent and the chord, it's equal. They are equal. It's equal to the angle in the alternate segment. So already I know that this is 50 degrees. I can see I have a diameter, and the diameter subtends 90 degrees. Already I know that that's 90. And I'll be writing reasons on the side. Okay? So I can write down maybe angle WRT is equals to 50 degrees. And that angle will be equals to angle WSR. You see, this is what I'm going to be writing. Then I know that WRT and WSR are equal. They are 50-50. Okay? I can write down R1 to be equals to 40 degrees. Already R1 will be 40 degrees. Okay? The reason for R1 to be 40, it will be sum of angles in a triangle. Okay? So I know that that one is also 90 degrees. So I have that. But now I can see I have angles in the same segment, which means that P1 will also be 40 degrees. So you see, and I'm writing down the reasons. I'm writing down the reasons here. So can you see, I can see P1 here, and that angle there will be equal because they are angles in the same segment. So I can write it in here. Remember, in paper 2, you're going to be given an answer book, and then you can do this on your sketch. The answer book will be having this sketch, so you'll be able to can write it there. So that if you miss out on writing the answers there, we are able to can check on the sketch, on the sketch to see if those angles are correct. Why? Let's go to the questions now. Why is VRC? So let's check our V. So our VRS 90. So already we know that that angle here is 90, but they're asking us the reason. So what is the reason for that? I know that the diameter and the tangent. So the answer will be tan, it's perpendicular to the diameter, because it is a theorem. Calculate the size of TRS. So we go to TRS. I already have it. So the angle there, can you see now? If I work on the sketch, my answers are already there. So TRS, remember with reasons. So my TRS will be equals to 40 degrees. How did I get the 40? Sum of angles in a triangle, because I'll first get that one is 90, and then I can get that. Okay. Right. The next question says, name with reason one other angle equal to 90. Do you still remember that? We got that angle to be 90, and this is 90, and they say one other angle equals to 90 and the reason. So which other angle equals to 90? Angle T1. So I'm going to get angle T1 equals to 90 degrees. There's one other angle equals to 90, and my reason there will be angle subtended by a diameter. Or if I don't want to write this, then I can write, say, angle in a semicircle. That's an easy one to write. Show that TWR is 40. TWR. So I know that this one is 90, that one is 50, and they're looking for TWR, that angle here. So if this is 90 and that one is 50, then my TWR will be equals to 40. So that's how I show it. So how do I show it? I'll first get angle T2 plus angle T3, it's 90 degrees. And I already know that that angle here is 50 is given. So which means that then TWR will be equals to 40 degrees. And the reason will be sum of angles in a triangle. Okay. All right. Can you see I've already got these angles on my sketch. Determine with reason the size of P1. I think we got P1 somewhere. P1 we said it's 40 degrees because that angle there is 40. So P1 will be equals to 40 degrees. And the reason there will be angles in the same segment. Okay. Show that V1 is equals to PTS. Show that V1. So let's check. V1. That angle here, V1. So V1, if I take VRS, S, that angle here, it's 90. And that angle, if I look at this triangle here, V1 is an exterior angle of a triangle. So I can write V1 equals to VRS plus angle S1. This one is a tricky question. Now, I know that VRS there, VRS is 90 degrees, so there will be 90 degrees plus S1. Again, I can then show that I know that S1, where is S1? This S1 equals to T2. See? S1 and T2 are the same. So I can write then, but S1 equals to T2. So let's check angle PTS. PTS, that whole angle here, PTS, it's equals to T2 plus 90 degrees. Can you see? So PTS there, PTS, it's equals to that. Sorry, this whole thing there, it's going there. Sorry. Right. Okay. So now PTS, we know PTS, if you check PTS here, where is PTS? PTS, the whole PTS here, will be equals to T2 plus T1. You see, right? So plus 90 degrees. So now, what are we going to have there? What did we say about T2? T2 will be equals to S1. So meaning that my PTS will be equals to S1 plus 90. If I check this and that, it will be the same, which means that V1 and PTS will be equal. So we have V1 will be equals to PTS. Okay. So now angle PTS equals to T2 plus 90 there, and then from there we know that T2 is equals to S1, and then we can work out that one backwards. Okay. So that is some bit of a challenging question, and then but after you've got all those angles here, you will be able to can figure out some of the angles that are equal because you've already written the values on the sketch there. Okay. Right. This is also a question in Euclidean geometry. So this is proportion. That's the one that I know you like most, because you know that if this line here it's parallel to that line there, this line over that line equals to this line over that line. That's an easy one. So we can then say x over 2 equals to x plus 2 over 3. Cross multiply, I get 2x plus 4 equals to 3x. Then I can then say my x value will be equals to 4. Right. Okay, if I transpose this that side, then 3x minus 2x is 1x, x will be equals to 4. That's a straightforward and easy one. But now remember, with reasons, so I must then write PM over MQ, it's equals to PS over SR, and the reason is line parallel to one side of a triangle. So it's one line, the line parallel to one side of a triangle, you see. So therefore you'll get a mark for the reason, a mark for the ratio, and that mark for the final one. Okay, so please make sure that you then write down the reason. I know with this reason, because you are so happy that you are able to can quickly do the proportion, you forget the reason, and we are losing easy marks here. All right. Now the next one on the geometry, I've just chosen these 3 questions in the geometry because they're quite easy. Here it says use the calculation to show that KLM, so KLM is this triangle here, it's similar to this triangle there. See? First of all, you must write the proportion. Right. So I'm given that KL is 10, LM is 15, MN is that, NK is 30, the diagonal is 20 units. So, and I'm given that it's a quadrilateral. So let's check the proportion. If I take LK over KM, so if I take LK over KM, let's look at the sides. LK, it's 10, KM, it's 20. If I simplify that, I get 1 over 2. So if I take Km over Mn, let's say Km over Mn, then I'll get 20 over 40, and that will give us 1 over 2 also. If I take the last one of Lm over Kn, I'll get 15 over 30, and that also gives us 1 over 2. So can you see that the ratios are the same? So what can I then say? Therefore, triangle KLKM, write it in properly, it's similar to triangle KMN, and I'll need a reason for that. So the reason will be sides of triangle in proportion, in the same proportion. Okay. So because it's half, it's half, it's half. You see, if the other one was not half, then I would not say that line, the two triangles are the same. Okay. Right. So these are basic questions that we really need to look and practice and make sure that we understand. See, with the other ones, we'll talk about the angles. The others will talk about the angles, but the others will talk about the sides. So in proportion, we deal with the angles, we deal also with the sides. There was one question also in the exam that says, what are the two reasons for similarity? Two reasons for similarity. See, angles, and you have seen that in PET also. So the angles must be they must be equiangular. So we have equiangular, angles must be equal, and then we've got sides must not be equal, but they must be in the same proportion. Okay, so they must be proportional. So the sides. So in this case, sides are in the same proportion. Okay. All right. I think with Euclidean geometry, if you can get this type of question right, we will be able to get marks from that. Please make sure that you attempt these questions in Euclidean geometry. They are not very difficult. We will going to take some few minutes before we start with the circles, angles, and angular movement. Okay, welcome back. Now the next topic there is circles, angles, and angular movement, which also is a very easy topic of 35 marks. So now in the given diagram, so please information read, put it on the sketch. Sometimes you find that the information is not there on the sketch. O is the center of the circle. Points A, B, C, E are on the circle. Diameter COE. Can you see there's a diameter there, COE. And the chord AB is also given there. Can you see they've even made life easy for you to say this is 90, that's 15, that's 15. Then CD is 6, so the length of that is 6. Calculate the height of DOE. So I'm looking for this height here. Okay. So in other words, I'm looking for H on my formula. So you can do, remember the formula for the height. So we've got one of the sides given there, which is 6. So I'm going now to go and write down the formula. Remember, you're going to get a mark for the formula. So, and that formula is then the formula sheet. It's also written that it is the length of the chord, you know, all those things are given. The distance for the height, the diameter, and then you've got, please copy it correctly. The negative first and the plus sign next. So I'm going to substitute. My height that has been given to me, it's a 6. So I'm going to say the minor height is a 6. The diameter, I know. The diameter here, I have my diameter, which is D. So do I know what is my diameter? I don't know. But do I know what is my height? Yes, I know. Do I know what is the length of the chord? Yes, I know. 30 squared equals to 0. So now I'm going to have 144 minus 24D plus 900. It's equals to 0. So remember, I'm looking for the diameter. So my diameter 24D, it's equals to 1044 if I take the 24 that side. So the D will be equals to 43.5. So meaning that my diameter there is 43.5. But I'm not looking for the diameter. What am I looking for? I'm looking for this length here, which is my DOE. So if I know that the whole length is 43.5, then it means my DOE will be 43.5, subtract the 6, and therefore we'll get 37.5 centimeters. This question usually carries 4 marks, 5 marks if you're going to factorize and work out the values, especially when you're looking for the value of x. You're going to factorize, you're going to or use a quadratic formula, and then you to get to the final answer. So you'll get this type of questions in the exam. Make sure that you really know how to do them. Okay, sometimes you find that you need to get to your diameter. You find that some of the lines you're given as that line DO, you need to find the diameter. So if I know my radius, then I can be able to get my diameter. Okay, so please practice all. Practice getting the value of H, practice getting the value of D, practice getting the value of X. So practice all those ones, so that then if it comes and they want you to find the height, you know how to do. To find the diameter, you know what to do. And the X, which is going to be the length of the chord. Alright. In the same question again, they say calculate the size of AOB. So which means that I've got AOB. I need to calculate the angle here. Right. So remember, for me to calculate the angle in this triangle, here's a triangle. I have a triangle. For me to calculate the angle here, I will need this side and that side. I know they are equal, but I know that the diameter I got it in the first question there. Okay, so I need to do what? I need to take the diameter that I got divided by 2. So if I got my diameter, the diameter that I got, which is 43.5, I divide that by 2 to get my R, the radius. So if I divide this by 2, I get 21.75, I think, centimeters, which is my radius. So this line is 21.75. This one is 21.75. I'll show you what I want to do here. Now I need the size of AOB. So AOB in this triangle here, I can only get it by using the cosine rule. Can you see how they integrate some of the topics into this? So I'm going to use the cosine rule. Why do I use the cosine rule? Because I've got two sides and I've got three sides given actually. So I've got that side, this side is 30. I've got the two sides. I can be able to get it. So how am I going to get it? I'm going to then write down the cosine rule. AB squared, it's equals to AO squared plus BO squared minus 2 times AO times OB or BO cos of the angle AOB. So can you see how I'm going to get the angle? So I'm going to have 30 squared 21.75 squared plus 21.75 squared minus 2 times, because AB, AO and OB are the same, I can just write 21.75 all squared and the cos of AOB, because they're the same, they are already. Okay, now from there what do I need? I need to find the cos of AOB, cos of AOB. So if I worked out all those, so in other words, I'm going to take this one, this one to the left, to the right, to the left, this one to the left, divide by what I have there, and then I'm going to get 0.04875, right? So remember, you use all the decimals that you're having, write them down. Then I can get my angle AOB by using the arc cos, then the angle that I'm going to get there will be 87.21 degrees. Okay, so that angle there will be 87.21 degrees. So I know that angle. I know that angle of that. There's no negative here, so I'm fine. The angle will be in the first quadrant. It's less than 90 degrees, so I'm able to get that. Okay. So I know that angle at the center is 87.21. The next question says we need the arc length ACB. So remember, I know that that angle here is 87, all right, 0.21. And now it is given there. Can you see sometimes the answers are given? So the angle, the 87.21 is the one that I got in 11.1.2, but it is already given there. So okay, so I'm going to use it because it's given there. So now correct it to decimal places is the radius of the circle. Now I'm given that the radius, you see now, and that one is given again. So we are given this too. We are given that angle there, it's 87.21, right? So I know that this, and now what do they want? They want us to calculate the arc ACB. That's an easy one. I was going to ask arc AEB, so that then you find that angle, but it's fine. That's an easy one because the arc that you're looking for is this one. The angle at the center is this one, and the radius is that one. So remember, for the arc, what do you need? The formula there, remember, it's as you go to your formula sheet, you go and look for that. Remember, the angle is in radians. So which means, what am I going to do? I'm going to change these angles to radians. So for me to get a radians to this, remember, changing from degrees to radians, formula for that. So that formula there, remember, it's a pi multiplied by the angle 180 degrees. So if I change this, it's going to be 1.52 radians. All right. So I'm going to substitute. My radius is 21.5. My radians is 1.52. And then I'm going to get 33.06. And that's centimeters because it's the arc length. Okay? So it's 33.06 centimeters. Okay. Now let's look at 11.2. This also, it's straightforward. Why I say so? Because if you go to your formula sheet and look for this word here, angular velocity, you'll get it, and it is attached to a formula. The only challenge there, it will be when it is given. You see, it is given r per minute, revolutions per minute. Then I must change that, because then the question that needs me to find what? Radians per second. So meaning that I must change my minutes to seconds. These are the only things that you need to look for, and these are the things that makes this question to be a bit challenging, because then if you use minutes and they want it in seconds, your answers are going to be incorrect. So they need the angular velocity. So your angular velocity is that sign here, which is called omega. It's equals to 2 pi n, number of revolutions. So what am I going to do here? I must change my 420 to seconds, radians per second. So I'm going to take this and divide this by 360, because I must change that to minutes. So I'm going to change it to seconds, remember, from minutes to seconds. So I'm going to divide that by 360. So I'm going to have 2 multiplied by pi multiply by 420 and divide this by 360. Then the answer that I'm going to get there will be 7 pi over 30. So r per second. So you can then change that. You can write it as decimal, it's not a problem, but you can leave it at that. Your calculators probably is going to leave your answer as 7 pi over 30 r seconds. Right. The next question says we need to find the circumferential velocity. You go to your formula sheet, you'll see that formula is saying circumferential velocity, and it's also meters per second. Okay, meters per second. So what are we going to do here? We are now going to have our formula, it's v pi d n. Right. I already know that my pi is 180, but I can leave my answer like that. So I can have it as a pi. Now my diameter, it's 240 millimeters. Can you see what do you want? So the conversions here in these questions, it's circles, angles, and angular movement are very, very important. So it's meters per second, but we are given the diameter in millimeters. So I must change my millimeters, 240 millimeters. I must change them to meters. So I'm going to divide this by 1,000. So I'm going to have 0.24 meters. Right? So that cancels out, and you must remember we move this. Okay, so I'm going to move this 2 times. I'm going to have a 0 there. Okay, so I'm going to have my diameter is 0.24 meters. Now I'm having my n. Remember my n, what did we do? We said it's 420 divided by 360. Then I can use my calculator, I get 5.04, and this is now meters per second. Okay, easy and straightforward. Okay, so please make sure that you read the question and see what they want. If they want it in meters per second and you're given millimeters, change it. They're given kilometers, you want to change it to meters, change the seconds, minutes, want to change it to that, please make sure that you change all those things. Okay, right. Okay, so please, these questions must not be left undone. In measurement, also, I just feel that these questions, we just leave them there. At the end is the last question in the exam, and I just feel that we leave them undone, and then we are really doing an injustice to this question paper if we leave these questions undone, because some of them are really straightforward. The formulae are given, then from there you just need to change a little bit, change that formula just a little bit, so that then you are able to can use it. You'll see when we do this type of questions. Now, read the question here. A cylinder, here is a cylinder, and a cone, here is a cone, have the same curved surface area, right? Both objects have the same radius. So in other words, the radius r here and the radius r are the same. And height. So the height here, there, and then we have the height there. Okay, we have the height there. Right. Now, it says the formula given here, we have got the formula of the cylinder. Remember, this is the formula for the whole cylinder, right? Pi r squared h, which means the area of the base multiplied by the height. The surface area of the cylinder, and if you see there's a 2 and a 2 in the surface area, you must know this part here is closed, that part there is closed. Okay. With an open cylinder, open on both sides, it will mean the 2 will not be there. The 2 represent that it is the area of this part here and the area of that part there. Okay. So the 2 pi r h, remember it is this circular part. So now the curved area of a cone, it's pi r l. The L here is for the slanting height. Can you see? That's a slanting height. We call it a slanting height. Okay. Slanting height. Now, the volume of the cone is given, always 1/3 area of the base multiplied by the height. Remember, the base of a cone is circular, so it will be area of the base multiplied by the height. Okay, so the height is also there. Surface area of the cone, remember, is the area of the base plus the curved area of the cone. So it's this part here plus the area of the base, which is a circular base. So I'm explaining this formula so that when you see them also in the then you are able to can recognize it. Say, okay, now you must understand them. You must not just memorize them, and you must understand them, and you must know how to use them. The first question there says, express the slant height. Here is our slanting height. Here is our h, here is our, and that is a perpendicular height. So we've got two heights in a cone, slanting height and a perpendicular height. Slanting height L of a cone in terms of R and H. So in terms of R and H, what type of a figure is this one? It's a right angle triangle. How can I use the L and the H and the R? Theorem of Pythagoras. So I'm going to say L squared equals to my r squared plus h squared. My L, they want me to represent L only, not L squared. So it will be the square root of r squared plus h squared. And the square root of r squared plus h squared is not r plus h, please. Correct. The next question says, if pi rl equals to this, so this is what is given, show that r squared equals to that. Obviously, what I need to do is just to substitute the value of L by that. Then I will be left with nothing else but the R and the H. The pi and the pi will cancel out. First I must do that actually. If I do this, the pi and the pi cancels out. I'm left with R L equals to 2R H. Now the L, now it's going to be the square root of R squared plus H squared. I can then divide both sides by R. The R and the R cancels out. I'm left with R squared plus H squared equals to 2H. Or square root, sorry. So if I square both sides, I'm going to have R squared plus H squared equals to 4H squared. Then I can transpose the H squared this side. I'll have R squared equals to 4H squared minus H squared. I'm going to have 3H squared. Can you see, this is what we are required to find. Okay. So as I say, this type of questions are not very challenging, but we need to look and work them out and practice them. Okay, so that's how we get that. Remember, this is given, so they say show that is like that. Use this one that has been given. You can start by substituting and then dividing both sides by pi and r, then you're going to get this. Okay, no formula used there, nothing. I didn't use any formula. I'm just given that these two are equal. Let me show that R squared equals to H squared. Okay. Take note of this because we might use it somewhere again. The next question says, express the volume of the cone in terms of H only. So meaning that my volume of the cone, I'll go to the formula sheet and check the volume of the cone. It's 1/3 pi R squared H. But they said it must be H only. They want us to represent it using H only. So how am I going to represent it by using H only? So I'm going to, I know R squared is now 3H squared. So I'm going to say V is equals to 1/3. Instead of writing R squared, what should I write? 3H squared. Okay. Remember, pi represents a number. So therefore, I'm going to say 3H squared multiplied by H. So my answer is going to be the 3 and the 3 cancels out. I'm left with pi. H squared times H will give me H cubed. So this is my volume in terms of H only because pi is a number. Okay. Right. 12.1.4a. These are a bit tricky questions, but we must first read and understand. They say if the two volumes differ by 54 pi, show that H is 3. So the two volumes, they differ by 54 pi. So what I'm going to do, I'm going to write down the volume of a cylinder minus the volume of the cone. It's 54 pi. Okay. So the volume of the cylinder, remember, if you go to the formula sheet, the volume of the cylinder is pi r squared H. The volume of the cone, we got it, is this one. We're going to use this one because we need H only, remember, because the answer must be H equals to 3. So I'm going to say the volume of the cone is pi H cubed. This is equals to 54 pi. The r squared, I already know. What is pi r squared? It's going to be 3h squared. So it will be pi r squared, pi multiplied by the r squared is going to be 3h squared multiplied by h minus pi h cubed. That should be 54 pi. Right. So what am I going to get there? I'm going to get 3 pi h cubed minus pi h cubed equals to 54 pi. If I subtract this, I'm going to get 2 pi h cubed equals to 54 pi. Pi on both sides. I'm going to finish it up here. So pi, I'm going to then divide both sides by 2 pi. So if I divide by both sides by 2 pi, I'm going to get h. So the 2 cancels out, the pi cancels out, and the pi cancels out. I'm going to get this is equals to 27. And the h, the cube root of 27 is going to be 3. So in other words, I'm going to get the cube root of that, and the h will be equals to 3. And see, the questions where the answers are given are a bit of a challenge, I know, because you work it out and then from there you make a mistake, you don't get the 3, and then you sit on that question because you're looking for the value of h to be 3. Please make sure that you go back and check where you made a mistake, then you rectify that mistake. Okay, so the value of h there, because they say the two volumes, they differ by 54 pi, the volume of the cone and the volume of the cylinder, they differ by 54. Write them down. The reason why they wanted you to get this is that you must use it here. Okay, and the other one is quite easy. Just replace the value of h squared by 3h squared. Can you see why that question was very, very, very important? 12.1.2 was very important because the r squared was supposed to be represented by 3h squared that you're going to use throughout your question. And the two questions that follow, we were using the r squared equals to 3h squared. The last question is find the value of r. Obviously, I already know what my h is. Can you see how these questions are interconnected? Whatever you get in this one. So if you get the first one right, the possibility is that the next ones you're not going to, if you get the first one wrong, the possibility is that the next ones you're not going to get them right. But please make sure that if you still use the ones that you got there in the next question, because we do what we call CAing when we're marking. Don't stop writing, please keep on writing, because one small mistake can make the whole thing to be wrong. But we try and make a point that we mark the understanding, but not that quick answer that we are having there. So please don't stop writing. Find the value of r. How do I get the value of r? Isn't it that I know that r squared equals to 3h squared? But I know that what my h is. My h value is going to be 3. So I'll say r squared equals to 3 into 3 squared. And r squared will be equals to 9 times 3 will be 27. Therefore, the value of r is going to be 3 root 3. And I can write that answer in decimal form. It's still fine. You can write it in a set form, which is also fine. So the answer will be 3 root 3, or you can write it in decimal form. So these questions, the measurement questions here, let me just write in there, it's plus measurement, because this is measurement. So your measurement questions, they will give you 15 marks. Your circles, angles, and angular movement will give you 35 marks. So you have that 50, and you have your Euclidean geometry, which is 40 marks. You have a trigonometry at 50 marks. Then you have those questions all those questions that analytical geometry there. So all these questions that we have done today here will give you up to 150 marks. So for you to pass, you just need 45 out of 150, but we want you to push your marks to over 100, which is possible. And on Monday, when you write your paper 2, please make sure that you start by passing. You start by looking at those questions that can make you pass. Then from there, you can get the questions that can make you move from a pass symbol to a next symbol that you need. Then towards the end of the time, then you try to push again your symbol to the desired symbol, which we are looking for, which is level 7, with all the learners that we are going to be writing this paper. And I'd like to take this opportunity to really wish you well in your exams on Monday. Please, this weekend, go and practice your paper 2. Make sure that at least you spend 3 hours writing one of the past paper in practicing for Monday, and mark yourself and see how many marks you get. And then you can do remedial on that work. Thank you so much and good luck.